Let's do this. 11 o'clock. I have 58 slides in a time frame of 60 minutes with demo. Yay, minute a slide. Let's do this. All right, password attacks. Quick, who am I? Offensive guy. I do offensive things. I do pentesty, red team, all that kind of stuff. SAINTCON keynote, if you know that story, that's hilarious. I love it. I own and cooperate Mark V Security with Dan Anderson Zoltan. We do a lot of consulting. Password audits is part of that, which is kind of feeds a lot of this. I'm super excited to be giving this Thursday early afternoon, right as the password cracking competition is about ready to end. So go use these techniques in the last half of the afternoon to go win a book. Put a ton of work into that contest. Full disclosure, there may be a bad word that slips in and out of my mouth because I warned you at the very beginning, I am an offensive guy. And it's more a reflection on me than you, really, is what that comes down to. So we're going to just get that out of the way. This is more of an intro level talk. Most of the industry veterans really won't get anything out of it. There are demos. There will be some motherfucking snakes in this motherfucking talk. And you will see what I'm talking about. Samuel L. Jackson. Okay, so some of the things that we are going to talk about. Password hashes, why they're used. I'm dropping memes in here. They may not be funny. I think they're funny. My wife doesn't think I'm funny, so who knows? What password cracking is, how you do it, rainbows. Yay, rainbows. Snakes, as I said earlier, there's going to be many snakes. How to go super lazy mode into cracking things and just not do anything, just drop hashes everywhere and let other people do it for you. Talking about sodium chloride a little bit. My opinions on John the Ripper, full disclosure, it sucks. Hashcat, way better, Hashcat++. We'll talk about buff horses and Hashcat runs because, demos and things and such. Am I qualified? Probably no. Grifter and I were talking about this. I don't feel qualified for anything. I do what I do, and SAINTCON accepted me, and you guys showed up. So therefore, yay, I'm up here. Shrug emoji. I absolutely adore passwords because it really is like the cornerstone of all of IT. You compromise somebody's password and you compromise pretty much everything that account gives you. If you're looking at it from like an IR perspective, if you know generally what users do and their behaviors, say you compromise a password, kind of monitor their behaviors, you start blending in really well. And you can start doing the things that they do and abuse the hell out of it. And users have terrible, terrible passwords lots of the time. And with cracking, power getting so good these days, it's really easy to crack and destroy terrible passwords. Also, like, what tech talk is not a tech talk without an XKCD comic, but I absolutely love this one. It's you bash someone's skull in to go get their password. Yeah, password hacking. Is that in your threat model? I don't know. All right. Here's the interaction portion of this. Here's your first snakes for the day. So some Python. Can anyone tell me what's really wrong with that? Please yell it out. The quiet SAINTCON crowd. Nothing. The password's in clear text. It's her password goes brr. It is basically running a check that says, if password equals her password goes brr, then grant acceptance. Probably is like once that gets exposed, everybody knows exactly what that password is, right? Any developers that have access to the source code, you can start to see that. So to solve said issue, the industry and a bunch of mathematicians all went, computation hashes, cool, let's do this. So it's a mathematical way to take input text or data, run it through an algorithm, scramble all the bits and bytes in a predictable manner where junk comes out the side that's not really readable by humans, but it's, like I said, it's consistent, it's the same every time, and if you change one little minor thing, the hash drastically changes. So you can't correlate test 1 with test 2 because they just look completely different. So math, cryptography, I'm not a cryptographer, it's very complex. But that's really what it is. So first demo, let's play with that. Cool. So more snakes, yay. Snakes, Python is great. So this is some code that literally just defines a function that returns a SHA-256 hash back from whatever a user inputs the data from. So we can demo this. Demo uno.py, password, test, it's a big garbled hash value. Like I said, run it again, it's the exact same thing. It doesn't matter how many times you run it, but if you make one minor change, maybe test, that you have no idea that there was only one character changed. And you do this for whatever, like, and it'll take as many character lengths as you want it to be. Bang, bang, bang. And there it is. So it seems like millions of different hash formats and hash algorithms that various different people use. Some of them less secure, some of them more secure. It really comes down to the ability to run this computational process and how fast a computer does that. So you'll kind of see that a little bit in a bit when we really kind of start getting into it. Demo 1, success, demo gods, somewhat love me today. Cool, so let's go back to our demo or our code or our snakes that I put up earlier. So if we make this better-ish, kind of really simple Python stuff, but instead of if password equals her password goes burr, we change it to the hash value. People don't exactly know that the original password was her password goes dir. Little more secure. I think I would agree. I was writing these slides and all of a sudden this popped up on my Reddit feed and I was like, wow, this is fortuitous. I was literally just writing these slides. Yeah. Always compare hashes, not passwords. So cracking. A lot of people, cracking is the process of, getting a password hash that you don't know what the clear text password is, and then making a shit ton of guesses to see what it is. So it takes that hash, takes a guess A, hashes A, do the hashes match? No, move on. A1, A2, A3, A, B. It's called brute forcing. I slides on that later. So lots of iterative runs of the exact same algorithm over and over and over and over. Once the hashes match, you can go, yep, I know what it is now. Hash identification, like I said, seems like a bazillion different hash types. MD5, MD4, NTLM, bcrypt. Really, if you want to look at a good list of them, you go to the Hashcat website and they'll give you all of the supported hashes that it is. It feels like you're just scrolling for days. Various different VPN configurations. People use different hash. Some people use half MD5, so they'll take MD5, lop off just half of the letters and just say that's good. I don't understand why, but like I said, I'm kind of dumb. I don't get things a lot. There are things that you can do to identify the hash. There's some tools in Kali. Hash ID's been around for a while. It's a Python module that you can install through apt, or I think you can actually pip install it as well. You can give it a hash and it'll give you the best guess on what it thinks that hash is based on the characteristics, lengths, characters used, things like that. I love recently, and I think this was last year, Hashcat actually pushed an update. And I've said Hashcat a lot, that's a big cracking tool we'll cover. But if you don't tell it what kind of hash you're trying to crack, now it'll make its best guess and go use one of these 4 that we think it is. And sometimes it'll actually just go, yeah, I'm 100% sure that's what the hash is, and then just start doing it. So phenomenal, because that was a lot of time I would spend, what exact hash is this so I can put it into Hashcat and actually start going. There's a lot of online stuff where you can drop hashes into it and it'll try and make its best guess on what it is. One of the ones I liked, Tunnels Up, that's Jack Resider, the guy who now does Darknet Diaries, which is a really awesome podcast that I recommend you go do. He's had that website up for long before the podcast. And then, like I said, Hashcat. At the very bottom, you can see the ID example hashes, and that's the huge list of all the hashes it supports and what they kind of look like. There's, again, as many hash types as there are in the world, it almost feels like there's that many techniques for password cracking. But we'll cover some of the major ones, really, that I use and have been successful for me. Brute force, wordlist / dictionary, hybrid combination of the two, which generally nets me the most positive results when I'm doing this kind of stuff. Mutations, rules, which are always really good, and some rainbow tables. I told you we're talking about rainbows. Brute forcing. It's pretty much as soon as you start getting into password cracking the first time, you start leaning heavily on the brute force kind of method. I did, and then as soon as you start getting much better, you can get more strategic at the way you do things. The best thing about it is it's the most thorough cracking technique you can use. The con is it could take a really long time. We're talking about years, thousands of years, tens of thousands of years to crack to run through an entire possibility chain for a specific hash, depending on the hardware or algorithm that's used. And this is literally trying every single possible combination of characters into a hash. So it's literally like uppercase, lowercase, digits, special characters, non-English characters, potentially. There's a lot of times, not a lot of time, but a couple times I've run into, word lists from other languages. Because if you start doing international stuff, French, Japanese, German, those people put in their passwords in their native language, it gets hashed. And unless you're aware of that, then you're obviously not going to get it. I have an example of that. Actually, my last SAINTCON talk 5 years ago, I pulled a hash out of, I think it was a hash. No, it was just a straight password out of GitHub somewhere. It was like, oh, it's Mandarin. Let's look at what that means in Mandarin. It was Mandarin for password, which was amazing and probably one of my favorite onstage moments ever. Yeah. Brute forcing, like I said, it could take a really long time. These are the potential number of guesses you would have to do in the English language for the various different character types and password lengths. As you can see, it gets exponentially crazy high. One length, 94 guesses, you could do that in millimeters of a second, like small fractions of a second. Only 10 character passwords is a massive number. I think that is 32 zeros when I counted that, and there is a name for it. It is 10 trigintillions possible guesses that you would have to make in brute forcing to make sure that you are guaranteed to crack it, theoretically. I don't know about you, but my computer's not that fast to do that much stuff in a reasonable amount of time. So therefore, word lists or dictionaries, you'll see them referred to as both, were created. It's a list of already cracked or compromised passwords that have hit the internet or people have manually compiled. You can get a lot of distance with this. The big one, which all of you should know, is the RockU word list. It is everywhere. It comes pre-installed in Kali, even. And it's one of the best like generalistic word lists that you can use to apply other techniques to. So using a word list, it's a list, usually it's a text file of just one word per line, and you take each line, run it through the hashing algorithm, and then compare the results. So you can get longer passwords much quicker, and you don't have to rely on the brute force methods. The con side is if the word isn't in the word list, obviously you're not going to be able to crack it, and you're going to get nothing, which sucks. It's one of the saddest things Hashcat finishes, and you're like, aw, nothing? No. Whenever you're cracking stuff, a good word list really makes or breaks the situation. So many of the attacks coming up after this that we'll talk about all rely on a word list. A good, solid word list will get you so far. Like I said, RockU is pretty much the most prolific one. CrackStation also has another good one that they do. It's pretty significantly bigger than RockU in just like this size, but it's really good. Daniel Messier, I don't know how to say his name. He also has a really good GitHub repository with a ton of stuff. Like it's not just word lists, it's like cross-site scripting, payloads, stuff like that as well. But he has a lot of word lists in there that are usually pretty good if you want to dig into them. What I use personally is I actually use a combination of RockU and CrackList. Combine them, sort them, unique them. It's big. I want to say 700 megs. I haven't looked at it in a while, but so sometimes it takes a lot to really kind of load up. And because I think I'm funny, I named that crackrock.txt because I think that makes sense. Hybrid stuff. This, again, like I kind of said, this is where I really start getting most of my success. And the idea is you take a word list base and then you do something with it. It's either like, we'll talk about rules, but you usually like brute force something on the end or at the beginning of it. So this is how you get the really terrible fall 2020, spring 2019 passwords. Because fall, spring, summer, winter, whatever, that's really easy in the word list. And then all you have to do is just brute force 3 or 4 digits, which is 0 through 9 at the end of it. So it takes much quicker to go through. It is slower than a straight word list because you're doing the brute forcing for each word in the word list. You're doing a lot of work for each one of those. And again, much like the word list stuff, if the base word is not in the word list, who cares? You're not going to get anything done. Mutations or rules. This is an insanely complex thing. I don't even necessarily always understand it because if you think regex might be hard, rules are significantly more harder to understand. But as a really basic concept, it runs each word in a word list against certain mutational rules. So it can be, the example I have is, replaces e's with threes, ones with bangs. So you can start getting some of the leet speak type passwords that, we've said for years, for a long time. I don't think we do it anymore. Just like use leet speak because it adds to the complexity. This is how attackers really start combating that. It does a lot more things like take the word list, word, double it. So password becomes password. Take the word list, double it, and then reverse the second one. So password, dirty, I think. Things like that. It'll capitalize certain things, lowercase certain things, and these word lists can get massive. I'll give you an example here. So these are some of the rules that Hashcat kind of supports, and it's small list. So you can kind of see, like I like at the bottom, reflect, duplicate a word, reverse, so you can see password, draws, using the p at ssword as the input. cycling out various different characters, things like that. So these can get, like I said, this is again just like the top like 0.5% of the toxic word or rule list. Again, like I don't really understand a lot of it. I think I tried to at some point and just went, yeah, this isn't applicable to me. Rely on the people that are like super nerdy about password cracking to build these things and, you know, give you something that works. Popular rules, ton of these come pre-bundled with Hashcat, so you really don't have to do anything. The best 64 rule gets a lot. Dead one rule is toxic, as you know, I just showed you guys. And then one I kind of like is the not so secure one. One rule to rule them all. They did a lot of research on the various different rules that were out there and kind of found the ones that got them the most results. So they would do a run, you know, nuke the results, do a run, and start comparing how many each one of them was able to get. I tend to use that one most often. Did it? Yeah, I duplicated slides. Yay, one last slide. So I said we're going to talk about rainbows. So these are rainbow tables. We used to use these somewhat frequently, don't anymore. It's kind of a depreciated thing. Grifter and I were talking about that yesterday, and he's like, I was going through a hard drive from a decade ago, and all of a sudden, I came across my rainbow tables and felt a little nostalgic. Rainbow tables were great because they would pre-compute all of the brute force results and just store them in a file. Then you just search for the hash. You don't actually have to do the computational process to come up with the hash. It was way, way quicker. Like you could potentially crack an NTLM password in seconds. It's like 8 characters, like whatever complexity. There's @ signs everywhere, bangs, numbers, uppercase, lowercase, doesn't matter. All been pre-computed, and you just search for it. Problem is, it's the storage requirements for these things are massive, massively big. So this is a project that is still running. I don't understand why. And we'll talk about why rainbow tables really aren't a thing anymore. But Rainbow Crack-a-Lack, they pushed an update like a year and a half ago even. But you can download the rainbow table there, but you can kind of see like the storage requirements we're talking about. So if we're looking at just 8 character NTLM, 486 gigs on disk. You just up that by 1 character length and jumps to 6.7 terabytes worth of data. So really difficult to manage. And part of the reason I think the data duplication village is a thing at DEF CON, because like transferring that stuff over the internet is horrific. And yay for BitTorrent, makes it a little easier. So that's another part of the reason why long passwords were long recommended. If you were running password or your AD and minimum character length of 8, that's not actually bad to totally store these days, the 486 gigs. Cool. So let's do some demos. Brute force. So this is kind of an example of how brute forcing works. Import hashlib, itertools. So I have a hash defined here, SHA-256 hash. Character set, I'm just going to do lowercase English characters. Not going to get anything crazy. The crack function just returns a SHA-256 hash of whatever you feed it. Brute just iterates A, B, C, D, all the way to AA, AB, AC, all the way to AAA, A, AAA, B. And then pretty much the main function for every character in the output of the iteration, we're going to run it through the crack. If that result matches the hash that we defined up here, hooray, cracked. If not, no, and then error out, we're done. So if we do that, demo 2.py, you'll see a ton of output. It's going to go really quick, but it's going to try all of these guesses. It's going to show you exactly what guess it tried, what the resulting hash was. There was a match, cracked, Meta, yay, that's me. So, like I said, if you do, 4 characters, not too terribly long, but if we, that was a good idea. I was going to do a 5-character password. Here, let's kill this. I just kind of want to show you. Of course, come on, Adam. Cool, so we change it. It's never going to match here, and you can kind of start seeing how long it takes. We're 4 characters, now we're 5 characters. You can see A at the beginning, taking a while to get through B, through C, and it just starts dragging on compared to how long it took to get through 4 characters. So the math that we showed in the quadrillion, billion different numbers, that's really kind of what it looks like. Cool. Brute forcing, hopefully that's good enough for people. Wordlist cracking, yay, more snakes. So this is, again, really basic kind of thing on the way all of this functions. We have another hash value, same crack function that we created earlier, it just returns the hash value of whatever we give it. And then for here, for word in, open the word list, in read, in code, do a bunch of stuff, strip out terrible characters, feed that into the cracking algorithm, and then again, spit out the exact same thing. So here we're gonna do demo 3, and we're gonna feed it the word list, which is just the standard rock U because it's so solid. Trying all of these words in there, da, 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 da. I think this one goes a little longer than the brute forcing one. Lots of things, trying. Correct, Cindy 33. Neato. So again, you're able to crack much longer passwords, much more complex passwords in kind of a shorter amount of time. And that's really what it comes down to, cracking things in a short amount of time. Hybrid. So now let's talk about that. Demo 4, again, for those who know the snakes, it gets a lot of the same code, just kind of changed up. Hash, character set 0 through 9, the same brute force function, the same crack function, but the only difference is here for word in word list, and then for the output of the brute force algorithm, so 1, 1, 1, 1, 2, 1, 2, 3, that kind of stuff. Combine them together. So you're going to join the word in the word list with the output of the brute force function, combine them, hash them, check them. This side. So what are we on? 4 now? Yeah, 4. So again, feeding it the rocku.txt. You can see a bunch of numbers after all of this. There was some dirty words in there that I saw. Family 24/7. Aww. This is a family-friendly con. And also more memes because family. There was nothing better than searching family on Google image results and actually coming up with a password-related meme. Yeah, that series sucked after halfway through 4. Don't just ignore it. It didn't become about cars anymore. Sad times. They went to space, I hear, though. All right, mutations or rules. So I was talking about all of the different, substitution type things. And this is going to be far more basic than like any of the rule substitution that Hashcat does. And full disclosure, it's not optimized at all. Because I'm lazy and did most of these last night, it does try the same attempt multiple times. So whatever. So we have a hash defined there, char set dictionary. So for lowercase a's, @ e to 3s, o's to 0s, 1 to bang. Again, the same crack function for word in word list, and then for C in our char set. So it's going to go find an A, find an E, find a 0, or O, find a 1. And then it's going to replace the A with that, E with the 0, or E with the 3, stuff like that. Again, send it all through the hashing algorithm, compare the different hashes. Demo 5. Got it. Thug life. Replaced the I or the 1 with the bang. And you can kind of see, like I said, it repeats some of them because the process really isn't optimized at all. You can see some of the changes. Tierra Santa, I guess, replaced the E, Tierra, whatever. Thanks, Rock You. There's a lot of good stuff in there. Thai 993R. Might be a Porsche guy. Or girl. Don't be sexist. Cool. Snake demo. So, how I said there's ways that you can crack these passwords without doing anything. There's a lot of databases out there where you just drop it a hash and it goes, yeah, div, we cracked it. Do we know what it is already? Here it is. The one full disclosure that I'm going to give you on that, and it's the same kind of disclosure I give you, about virus total, is if you're working with a customer or sensitive hash types, do not submit them to online resources because that leaks and the owners of the database can have access to all that stuff. So if I'm in a customer engagement, I 100%, 1,000% never throw them into stuff like this. But if you're get your hands on the latest juicy data breach that gets posted to RAID forums or something like that, and you just want to start cracking away at them, sure, throw them in there and whatever. That's already public domain anyway. But it can save some time. So it's really worth pointing out. There's some other solutions out there where you can pay smaller fees and it'll queue up your hash in their own cracking infrastructure, and you can pay a small amount of money to potentially crack it. Again, you don't have control over their processes of cracking it, so you may or may not get it. If you're trying to be advanced, go with your own stuff. And this is all part of the reason why we built our own password cracking rig, is to keep all of this stuff in-house. So I said we're talking about sodium chloride a little bit, and that's password salts. So this is pretty much the reason why we don't use rainbow tables that much anymore. Because, well, I got a graphic. Let's do that. That'll be easier. Thank you, Okta. I like Okta. So the infrastructure of this is website or service takes password, adds its own value that they know, combine the two things, hash that, and then store that resulting hash. And then go through that same process anytime somebody adds they submit a password for authentication, or whatever you submit passwords for. It's a value known only by the company, and obviously you're not going to be able to crack something like that if you don't know the salt value. You can, if you know that they are salting and you know the way that they're salting, you can brute force both of them. So for a word list, if you know the salt is coming in after the main clear text password, word list password, brute force the salt, much like the hybrid stuff that I just did with the digits at the very end. You can do stuff like that. And that's how you can compromise it. It just ups the complexity and computational requirements that are needed to be able to successfully crack something like this. And a lot of times, these salts are stored in the database directly, so if it gets compromised and dumped to the internet, the hash anyway. Yay. Sometimes it can be a pain in the ass. Other times it is not. Go back. Let's see if I, yeah, so sometimes, just kind of on salts themselves, sometimes it's a per implementation salt. So it's the same salt gets added to every single, password in the database. Once you know that, obviously, there's super easy to do. More complex implementations will do unique salts. It'll generate a unique value at every single entry in the database. Obviously, much harder to crack. Cool. So some password cracking tools, because obviously you don't want to have to write your own snakes to crack passwords. There's a good amount of stuff out there. Yeah. that do unique or niche kind of things. John the Ripper was the big thing for a long time. It supports a lot of things. I think it was one of the first ones to get support for CUDA, which we'll talk about in a little bit. I think it absolutely sucks. The user experience is horrific. It was designed in an age when I don't think UX design was actually a thing. Like, just didn't exist. I may be wrong, I don't know. Hashcat. Hashcat is absolutely phenomenal. This is the de facto standard in password cracking these days. It supports everything you ever would want or believe to be supported, plus some. This is a tool that I'm still learning all of the various different techniques that it supports. And it's open source, it's cross-platform, it's on GitHub. I think Hashcat came out of the password cracking competition at DEF CON. It was the guys that were doing really well there were like, yeah, we're gonna go write our own better thing. And it is insanely better. Again, constant development. So they pushed the update where it automatically detects hashes about last year, I believe. And then that sweet, sweet CUDA support, obviously. And it's out of the box almost. All you gotta do is install the NVIDIA drivers, and boom, you can use GPUs, which we'll talk about. So how you use Hashcat, it's pretty much like, here's all the attack mode flags that I use, and then we've really covered here. 0 being straight dictionary attack, A1 combines word lists together and does stuff like that. 3 is brute force, 0 and 3 I use quite a bit, and then 6 and 7 are the hybrid, whether it's prefix or suffix. 6 being brute forcing the suffix of the password, 7 being brute forcing the prefix on the password. I don't know where 2 went, or 4, 5, I don't care. The other flag you need to give it is potentially M being the hash type that it's going to be. Hashcat has its own individual numbering system for all of the support, or all the hashes that it supports. So you have to go to the documentation and look at it. And I think that if you do like hashcat-h for help, it'll spit out a bunch of it, which we can look at. And like I said, M has been removed. Well, you don't necessarily always have to use it in all situations to tell it what hash it is, because it tries to identify it for you. Back in my day, you'd always need it, or else it just wouldn't do anything because it didn't know what hash it was. Masks. Masks are, if anyone has done like IP subnetting, it'll be like a somewhat similar kind of thing. So a mask is a set of characters at the end of it. Each character point, so character 1 in a password is denoted by a question mark. So question mark and then a shortcut value. L being lowercase numbers, U being uppercase characters, D for digits, H for hexadecimal values, capital H for capital hexadecimal values, S special characters. A, I like that one a lot because it combines lowercase, uppercase, digits, special characters all into one. So it says for this character position, it can be any one of these that we're going to try and potentially brute force. And then B for binary values. I stay away from B just because it adds to the complexity of the cracking run. So again, masks are pretty much only used for brute force or the hybrid where brute forcing is applicable. And this is kind of example how it can be done. So if we have question mark U, that's saying for first character position, that's going to be an uppercase. Everything else is going to be lowercase until the last 2 of the brute forceable characters are going to be digits. This is how we get our spring, fall, winter, 2020, 2021, fall 9999, stuff like that. Once you understand that, it's really easy to build your, targeted brute forcing of certain things. I get a lot of ground on this. So here's kind of what they look like. I know we just went through all of the flags for it. Straight dictionary attack, A0, give it the hash, give it the word list, and it goes. Super straightforward. An example, if you get any hashes coming out of responder, which if I love that tool, feeding it RockU, it'll go start cracking. Again, brute force, talking about the masks. You're giving it a list of hashes. Again, upper, lower, 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 digit, digit. I think super straightforward. Hybrid suffix. So again, A6, this is cracking, again, the brute forcing on the suffix of the word list. Again, it's, I think, all fairly straightforward and self-explanatory. This is the one that sometimes catches me up. You kind of got to flip them for 7 when you're brute forcing the suffix. Once you get it, makes sense. Yeah, brute force. And then the list of word lists coming out of the word list, or the hashes. R, again, those are for the rules and the rules files that we talked about that makes the substitutions all over the place in the potential guess. You apply it to any command that uses a word list. That's really all you need to do. And it runs. Demo 2.5. So let's look at Hashcat in the way, kind of Hashcat does it. Kind of go over the examples here. So Hashcat, if I could type a 0 in mode, I'm just going to give it 1400, which is SHA-256 or SHA-2 256 in their documentation. And then we're going to do hash1, which is the exact same hash that we did in the snakes demos. Hash1, going to give it to RockU. So straight brute for or word list coming out of RockU. Invalid argument specified. Oh, I need to give it a -A0. Attack mode 0 M. Cool. No hashes. Which one? Yeah, this was 2, right? Or what command did I give it? Oh, yeah, not hash1. That doesn't exist. So it's going to do its thing. You're going to have like a repeatable status update here. And because it's big, oh, that didn't work. Of course something was going to break here. Which one was, so we can look at demo 2. Oh no, that was straight brute forcing. That wasn't a word list. So let's do 3. Lower, 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 because we know that's really kind of what it is. It's going to do its thing, load everything up. Theoretically, there we go. There's the hash. It found cracked in meta. And whenever it finds a successful hash, it adds it to the Hashcat pot file, so it doesn't need to re-brute force things that you already know or have already cracked in the past. Cool, so that's really what it looks like. You can get a lot of stats coming out of here. You can see the progress on it. You have a little menu at the bottom that you can ask for updates. You can pause cracking sessions. You can save them off, resume them later, stuff like that. Because nothing's worse than loading up a massive cracking job that is going to take a week, and just you flip a breaker in your house. Ask me how I know. And then you lose all of that work. And as you may have noticed, this actually, it took Hashcat way quicker to find that than just the standard Python, single-threaded Python. Hashcat is insanely optimized to do these things really quickly. 3.5, so again, we're going to do this on a word list, so A0, 1400, we're going to hash 3, so again, same hash, RockU, and it found it, Cindy33. Again, all of the stats coming out of it, it took 1 second just because it rounds up. Cool. All the hybrid stuff, so we're going to do 6. Again, just kind of the exact same stuff we've already done. You can see that I've already done this in my bash history. So again, take RockU, brute force digits on the end of it, go! And it's done. The top, family 24/7. Again, we already knew that, but 4, 5, more of the mutation stuff. So here we will 5 which one was I don't even remember what hash that was. Again, really late night last night. Let's do our see, opt /hashcat rules, no, not the build stuff. Rules, you can see a list of rules in there. Toxic dot rules. Oh, I think this was just a straight word list. So let's do all the way down to attack mode 0, just so straight word list. R rock you, and then we need to give it. Theoretically, that might work. I don't remember what this demo was. Like I said, I'm terrible at what I do. It's nice when you disclose that going in. Like I said, well, we can see kind of like the status. If you keep hitting S, you can see overall speed of Hashcat as it's going in. So 16,000-ish kilohashes per second. Progress as it's going through all of the potential guesses. So you can really start seeing how long it's going to take. Hashcat gives you an estimation, 1 hour, 3 minutes. Again, this is all just on the MacBook CPU, so it's not gonna, it's gonna take significantly longer than a good, awesome GPU setup. Quit that out. Cool. Cracking speeds. This is probably one of the most common questions at the password cracking village competition that I got from people going, how quickly is it gonna take you to crack password XYZ? I need more data. What kind of hashing algorithm is it? Again, what kind of password is it? Do you know the length of the password? Do you know the characters that are used? What's the password policy that resulted in that? And whenever we talk about cracking speeds, it's generally how long it takes at the most maximum amount of time. So like how long can you get through a word list or a brute force without having solved anything? Really is kind of what it comes down to. This is kind of where we start going into math. Funny, I got, it's 13 minutes, so I have enough time to do this. My math teacher in high school pulled me out aside. I was a terrible student in high school. He pulled me out, he goes, hey, you want to do computers when you grow up, right? I said, yes. He goes, cool, well, you're going to have to learn more math. I said, with all due respect, sir, that's why they invented computers. Did not like that. Get back in there. Don't ever talk to me again. But if we're talking about math, like the cracking duration that we talk about is the length of the duration, total possibilities divided by guesses per second. Super straightforward. If we have 1 million possibilities at guessing a certain password, if we're able to do 8 guesses a second, 125,000 seconds, 2,000 some odd minutes, 34.722 repeating, of course, hours. If we're able to triple that, so go 8 to 24, you can kind of see how drastically that number starts dropping. We go from 34.722 repeating, of course, hours to 11.57 hours. And that's really where the game of password cracking comes in. It's how many guesses per second can you do as password requirements get longer, the possibility and numbers get significantly bigger. How many of them can you squeeze into a second to be able to crack something in a reasonable amount of time? Everyone's definition of reasonable is different. NSA's definition of reasonable is not my definition of reasonable, but they have the money and resources and GPU farms to do that. So again, how do we increase the guesses per second? We give it bigger, better hardware, faster computers. Let's go to the moon. And how do we get faster computers? Really the way that we've kind of settled on was really CUDA. I said CUDA earlier. CUDA changed the game for general compute. What it did is, well, back in my day, you would have binary drivers that were closed source and you could only send data to graphics cards that would result in making graphics on your screen. I think it was 2007 or 8, I looked it up the other day, that NVIDIA released CUDA that said, now we're giving you API support where you can give this graphics card any kind of computational you want. And as it turns out, graphic cards are really, 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 really fast at doing math, which is, password cracking. You will see the miners have also done it because Bitcoin or cryptocurrency mining is essentially like brute forcing stuff. They give you a hash and go, hey, give us the value. First person to give us the value gets the money. Or if it's not tied to money, it's other stuff. So with CUDA, you could throw all of this computationally intensive work, like hashing things, into the GPU and go. All of a sudden, it just like opened up the world. NVIDIA already had SLI a couple years earlier, where you could scale cards together. So it was like you put it was way before 1080s, 2 cards, like one card would generate the top half of the screen, the other card would generate the bottom half of the screen. And you get to split that load between them. At first, it was like only 2 supported cards, and then they just got rid of like limits on the cards that you could do in the drivers. And then it came down to hardware, how like can we build the motherboards and stuff to support large cards, and then just get a almost like supercomputing level computation at home, theoretically. Well, at least supercomputing 10, 15 years ago. I think my password cracking rig is like way faster than the stuff from that age. CPU versus GPU, it's like having sickly horses versus really nice buff horses. Because who wants to ride a sickly, terrible horse? I feel really bad for that horse. There was a whole article on those terrible horses that they took away from their owners, which is good. But that stud on the right, absolutely. Get me on that thing, let's go. And this is what it has kind of turned into, which I think everyone is kind of aware of that. So CUDA versus SLI, you have warehouses full of GPUs. Just in this case, I believe it's just mining silly cryptocurrency. Saw some article that said some of these warehouses consume more electricity than some countries do because it's just ridiculous. But with CUDA and stuff, you can really start scaling to that level of computational power. We have this. This is at the password cracking village in the village and contests area. This is a couple people's cracking rigs kind of out for display. I think mine's the big red one, or ours, I should say, Mark V's. It's all corporate money. That's the big red one. Fan's broken, I know, and I understand everybody that told me that. It's pretty awesome. Currently, it has 8 1080 Ti FTW EVGA cards in it with a brand newish 3080 Ti FTW3 in it. I don't think that the 3080 is not hooked up right now because it causes lots of power issues at my house. I did burn out every outlet in an entire wall across multiple circuits running this thing because it has up to 4 1200 watt PSUs in it, and if one PSU per circuit is really the only thing that you can run on that circuit without mass chaos, pandemonium, flipping circuits, as I talked about earlier. This is a ton of fun. You can build a bunch of the stuff like that. Bash Ninja's rig is that front one kind of underneath ours. That's got the new 3090s. Those are really quick. And each successive GPU generation just keeps getting faster and faster and faster. That's why password policies have to be a moving target. With that cracking rig, we're talking like super low end of computational power, the base NTLM in Windows that we just can't get rid of. I can do about hundreds of millions of guesses per second on that guy. Getting through the entire character set, upper, lower, digit, special characters, up to an 8 character length takes me about 4 or 5-ish hours. So 8 character passwords are no longer a thing that should be anywhere. Use this to, we come into organizations, we do password audits, dump the SAM database out of Active Directory, feed it into this massive guy and see how many we can crack. What are the commonalities between the things that we do crack? Are 30% of your users using the slogan of the company for your password? Yeah, that happens quite a bit. So you can start getting a lot of insight into this. I've talked to some of our customers. They're looking to build a rig in and of themselves, so they don't have to pay our consulting fees to come in and do it. But I love that. I love playing with the hardware and building these things and seeing bigger numbers. That's why when I played WoW, I played DPS class, because big numbers. Let me see the bigger numbers. Let's go. So yeah, come by, come see that. I'm there, all day, really, in answering questions about passwords and password security, just because I love it very much. Arigato gozaimasu. Go forth and crack passwords. I'll probably not take questions here. Just go find me in the password cracking village. Be happy to talk to you. Cool.